Hey everyone, welcome back, and today let's solve Leetcode problem 3392, titled Count Subarrays of length 3 with a condition. So we're given an integer array nums, and we want to return the number of subarrays of length 3 in this input array nums, such that the sum of the first and third numbers in this subarray equals exactly half of the second number. So in example 1, we have our input array nums to be 1, 2, 1, 4, 1, and in this case we have our output to be 1. The reason why is because we only have one subarray that is actually length 3, where the first value or first element of that subarray plus the third element of that subarray is equal to that middle value or second number divided by 2, right? That's kind of what the definition of half would really be. And in this case, the subarray that kind of meets that requirement is 1, 4, 1. The two outer numbers, if you will, or the first and third numbers, are 1 and 1. If you take the sum of those, you will get the sum. They will actually be equal to the middle number divided by 2, because that's the half of the middle number divided by 2. In this case, 1 plus 1 is indeed equal to 4 divided by 2, because 2 is equal to 2. Right? It is 3 elements, where 4 is equal to 1 plus 1 parentheses times 2. In example 2, we have our input array nums to be 1, 1, 1. In this case, we only have 3 elements, and so we only have one possible middle number, again hinting things to come, but we only have one possible valid subarray, which would be the entire input array nums itself. And in this case, it just doesn't meet the requirement because the middle number 1 is not actually half, or rather twice, of the sum of the outer two numbers. So we have an output of 0. There are 0 valid subarrays, or rather I should say, valid subarrays works. So for the constraints here, we see that the length of our input array nums is going to be between 3 and 100, and any value in the input array nums is going to be between negative 100 and 100. Now, what does this really tell us? Well, first of all, you're going to have to just leverage the fact that this really is a Leetcode easy problem, and typically in most Leetcode problems, when applicable, a single iteration solution of the input is almost always going to work, and this problem is really no different, right? Really, we just iterate over the input array for every element once, and you basically treat every element to be a possible middle element. And if for every element, the outer two, or the number next to it to the left and the number adjacent to it to the right, have that property of having a sum that's half of the current element, we know it's a valid subarray because it's 3 elements, right? So instead of actually having to use nested loops here to check for all the different possible subarrays, given the fact that we're guaranteed that we only check for length 3 subarrays, we know we can just have a single iteration of the input array nums and find every possible valid middle number to form its neighboring 2 elements to be a valid potential subarray, right? So let's go ahead and begin this single iteration solution. And before we even start iterating through the array, let's actually initialize our result. I could also call this count. The whole point of this result is basically to actually keep track and store the total number of valid subarrays that we find, or valid possible middle values, as well as another way you can think about it, that we find as we iterate through the input array nums. Now, for I in the range of length of nums, why don't I just iterate through the length of the nums generally? Well, because I want to care about the indices as well, because I want I plus 1 index and I minus 1 index, because that's going to form our 3 consecutive subarrays that have that potential valid property. Now, the first thing that I have to consider is, am I going to go out of bounds? Meaning, is I going to be less than 0, rather, is I going to be equal to 0, or is I going to be the last index? Because again, we're treating every single possible index to be the possible valid middle element for all the subarrays. And so if it's not even in the range, meaning if it's the 0th index, or if it's the last index of the input array nums, we know it won't be valid because it wouldn't actually form a valid subarray, as we would get an index out of bounds. So we first want to check if I is greater than 0, because we're checking I minus 1 index, and so it has to at least be 1, and I is less than the last index, meaning the length of an input array nums minus 1, because again, keep in mind, input arrays are actually 0 index. So if I is greater than the 0th index, meaning it's at least the first index, so we can actually compare I minus 1 index without going out of bounds, and I is less than the length of an input array nums minus 1, or the last index, meaning we can still compare I plus 1th index without going out of bounds to actually check if this is a valid potential subarray, with the current element I being the middle element. Now, if both of those conditions are true, meaning we don't get an index out of bounds, and we want to actually check for this main condition of the sum of the first and third numbers equals exactly half of the second number, right? The second number would kind of be that middle number over this current index I. So how do we actually check that? Well, we want nums at I plus 1, that's the third element, plus plus nums at I minus 1, that's the first element, right? That's like the left element. We want that to equal the current element I divided by 2, right? Because again, the current element I divided by 2 is half of that number, and if that's equal to the sum of the left and right portions or elements of the subarray, basically I minus 1 and I minus plus 1, we know it's a valid subarray. This is a potential valid element, and so if it is, we can increment our result by 1, indicating that we found one more valid subarray that we iterated through and saw in the input array nums. And effectively, once this for loop is actually done executing, once it fully terminates and we iterated through all the potential valid elements in the input array nums, we're going to return what our result is, because it's going to store the total number of valid subarrays in the entire input array nums. So unless I made any syntax errors here, this should be accepted and there should be a valid solution. So let's go ahead and verify that. And as you can see, this really is just about as efficient as you can get it to be. So on a high level, what are we really doing here? We're basically iterating through all the indices of the input array nums, considering them to be possible valid middle indices or second numbers, and as long as their outer two or adjacent left and adjacent right properties, or rather elements, have that property of having a sum equal to half of the current element, we know it's going to be or form a valid subarray with these three current elements, and so we're going to increment our count by 1 and effectively return that count after we iterate through the entire input array. So for the runtime complexity here, it's actually going to be just very straightforwardly, it's linear, right? It's just big O of n. Why? Because this really is just a one-pass solution where we iterate through all the indices really once, except for all the indices exactly once. And for the memory complexity or space complexity, it's actually going to be big O of 1 or constant, because we're not actually using any auxiliary memory or any extra data structures. Really, the only extra integer that we're using is this result, but that's not going to go linearly with the space or with our input. And so this is actually a constant big O of 1 memory or space complexity. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.